So what do we get for the last, these three right here? 58, 35, and 105. Okay. Now, so that means that, so now we can go across, and why don't you guys tell me what these three are, okay, when we add those matrices. Yeah.
The second one is subtraction.
Oh, subtraction. So 1 minus 1 would be 6. Yep. 6 minus 3 would be 3. Whoa. Okay. Okay. Now we're back online here. Okay. So it would be 6, 3, and 13. Okay. Now this one we can't do because the dimensions don't match. What are the dimensions of this one? And remember, it's rows and then columns. So this would be a 2 by 3. And this would be a 3 by 2. Okay, so dimensions when you're talking about matrices and doing operations are really important. So we cannot do these. Cannot.
There's no way to deal with that?
Nope. They just don't match up, so you can't deal with it, right? Matrix addition can be used to represent translations of a geometric figure, right? So we have this geometric figure here. And remember that this is the x coordinates and this is the y coordinates. So this would be 1 point, this would be 1 point, this would be another point, this would be a third point, okay? And so we can graph those. -3, 2, right? 1, 3, and 2, -2. We have our triangle. Let's graph the triangle and its image after a translation left 2 units. So that means everything would move over here, right? Okay. Left 2 units. Write a matrix equation to represent this translation. So if we started here at -3, 1, 2, and 2, 3, -2, what would we have to add to that to get to this new location, which is, so this would be -5, 2, -1, 3, and 2, -2. Oh, whoops, no, 2, 0, -2. Okay? So what do we need to add to each of these to get that to work? Do we do anything to the x's? Okay, what do we add? Yeah, -2, -2, -2. Do we do anything to the y's? No, just 0, 0, 0. Pretty straightforward. Okay. Let's look on the next page. I'm going to let you guys look through that stuff a little bit because I want to get to the hard stuff that's just a little bit more complicated. All right? And that's matrix multiplication, okay? And so everybody work with me here, right? I want you to say x, stick your fingers up just like this. X, y. X, y, X, y. Everybody together now, okay? X, y, okay? Ready? So, when we multiply by 2 matrices, okay, there's a couple things that are important. But what you do is you take the row x, right, horizontal, and you match it up with the vertical y, okay, in each row, in each column, okay? So let's think about that. So you'll notice you can start looking on your sheet and see how what they do is we take the first one gets multiplied by the first one in the row gets multiplied by the first one in the column, and then the second one in the row gets multiplied by the second one in the column, and then they get added together.
Whoa.
Okay. No, I don't think they could. So, but you can think of it sort of like distribution, okay? And and why I talk about this is because the first one in the row matches up with the first one in the column. The second one in the row matches up with the second one in the column. If there were 3 or 4 or 5, same thing. You just go boom, boom, match them up, all right? Now, there's one other concept that I want you to get that we need to do, and that is, just like with addition, there's only certain ones that we can do, right? With addition, they have to have the same dimensions. With addition and subtract, or with multiplication, right, the interior dimensions have to match. So let's show what that means. What are the dimensions of this? It's a 1 by 2. This is a 2 by 3. So in other words, the number of columns have to match up with the number of rows, okay? And the exterior dimensions, so this is a little text. Every time you do a multiplication, you should write down the dimensions and see whether it's okay to do that, okay? And if the interior dimensions match, then you can do it. The exterior dimensions tell you how big the matrix will be, okay? The resulting matrix. So my resulting matrix will be a 1 by 3, and you can see that's right here, okay? So when I multiply the first row by the first column, that one is going to go in that position, row 1, column 1. When I multiply the first row by the second column, that one is going to go in here in the first row, second column, and so on. All right? So let's do one. You guys can have that example. Let's do one that we can see. And I think if you flip on the back, I think that's the spares right there. Is there space? No, not really. Okay. So let's check it out. So what are the dimensions of this one? It is a 3 by 2. Okay, and this is a 2 by 3. These match, so we can do it. Okay, the resulting matrix is going to be gigantic. It's going to be a 3 by 3 matrix. Okay. Now I apologize, I didn't leave you enough space to kind of work with this, but so in the end, I'm going to end up with a matrix with 1, 2, 3, 4, 5, 6, 7, 8, 9 entries. Okay, the one that goes here is the one that's for multiplying the first row times the first column. So I'm going to say 1 times 3 plus 0 times 7, which is 3. Okay? If I want to find this one, right, that is the third row, third column, so I'm going to say, what? 1 times 3 plus 0 times 7. Okay, so if I want to do this one here, right, that is my third row, third column, so I'm going to use my third row, third column, and I'm going to go like this, boom, and I'll get 4 times 6 plus -1 times 2, right, which is 24 minus 2, so that would be 22. So I can do them in any order, but usually I do them like this, and I go through and match them up. All right, so now I'm going to do first row, second column. 1 times -4 plus 0 times 0 is -4. 1 times 6 is 6 plus 0 times 2 is 0. So this entry is going to be 6. All right, let's do this one. So which row do I need to do and which column do I need to do? Second row, second column. So I'm going to say +8 plus 0 is +8. Okay? So why don't you guys fill out the rest of that? So this is what I got. Did anybody get anything different? No? All right.